In this video, I'm going to show you how to sketch the derivative of a smooth function from the function's graph. So here we're given this function f of x, and we want to sketch the graph of the derivative f prime of x. Remember, the derivative f prime of x just represents the slope of the graph of f of x at any point. To get started, why don't we find the points where the graph of f of x has a slope of 0. For example, at the bottom of this valley here, its slope is 0 because it's just flat across. So the derivative at this point would have to have a value of 0. So same x-coordinate, but now the y value is 0 for f prime of x. And now let's check whether the slope is positive or negative on each side of this 0. Looking on the left side, here the slope is negative for the function. The tangent lines are all downward sloping. So the derivative should be coming from the negative side over here. The values on this side of the 0 should be negative because the slope of the function is negative here. On the other side, though, the slope of the function is positive. The tangent lines are all upward sloping, so the derivative should cross into the positive side of the y-axis, taking on some positive values. And now we can infer that the derivative will just continue on positive, like is shown in the function, and it'll continue on negative in the left direction. That is to say, the tangent lines become sloped higher and higher and higher, more positive as x increases this way, so the derivative should be getting more and more positive. Whereas on the other side, as we go to the left, the slopes of the tangent lines get more and more negative. They're more downward in the negative direction, so the derivative gets more and more negative. Now, just to finish this off, let's go ahead and draw in that line. Positive this way, and negative that way. So there we go. There is our graph of f prime of x. Here's another problem. Similar to the previous one, but this time we have a function g of x with a slightly different graph. And again, we want to sketch the graph of the derivative, g prime of x. Now, to get started, why don't we begin again by looking for where the graph of g of x has slope of 0. Coming from left to right, we see its positive slope, and then 0 up here, and then negative slope, and then 0 down here, and then it switches to positive slope again. So at these two x values, the value of the derivative is 0. So let's go ahead and put down these roots here. Now let's go ahead and draw what the derivative graph looks like around these roots. So for this root here, on the left of the root, the function is increasing. So derivative should be positive. So coming from the left, it should look something like this. And then on the right, the function is decreasing. Tangent lines have downward slopes. So derivative is negative. So it should look like that. Now over to this point here, on the left side here, the derivative is still negative. The function's decreasing. The tangent lines have downward slopes. So derivative is coming from the negative side. But then on the right side, the slope is positive. The function is increasing. So derivative should be positive now. Now we can just go ahead and infer the shape of the rest of the graph. It's just going to be an upward parabola. Looks like this. It goes down and then has to come back up for this root here. And then it keeps on going upward. Same thing on the other side as well. Going upward. So there we go. There's our graph of g prime of x. Alright, here's another function, h of x, and again, we want to sketch the graph of the derivative h prime of x. As we usually do, we're going to start by looking for points on the graph of h of x where the slope is 0. And going from left to right, the first point would be up here at the peak of this hill. That is slope 0, and then where else? Well, negative here, and then 0 over here. Slope is 0, then positive slope over here, and then over here, the function looks flat, and that is also 0 slope. So all of these points here are going to be 0 slope. Maybe we can just place our 2 points at the endpoints of this interval. The whole thing is going to be 0 slope. So now let's begin to draw our derivative graph. So at this point, 0 slope, so value of derivative is 0 at that x-coordinate. Same over here, value of the derivative is 0. Same over here, value of the derivative is 0. It's also 0 all the way in between, all the way up to this point, at which it stops being 0, it starts increasing again. So everywhere in between is also 0. Okay, so now let's go ahead and draw the behavior of the derivative around each one of these points. Starting with this point over here, looking to the left, the function is increasing. Tangent lines slope upwards, so the derivative is positive on this side, and it's coming down to be 0 here, and then the function starts decreasing. Tangent lines are downwards, negative slope, so derivative is negative going that way. Okay, and then so how about over here at our next point? On the left, the derivative should be negative because the function is decreasing. So negative over there, and then on the right, the function is increasing again, so derivative is back to being positive. Now at this point, on the left, the derivative is positive. Tangent lines are sloping upwards. So over here, and then of course on this interval in between these points, the function is flat, so derivative is 0. And then at this final point here, if we continue going right, the function starts increasing again. So the derivative must be positive going to the right there. Now we can just go ahead and connect up our template here to draw in the rest of the derivative graph. So here it goes down, but then it has to come back up to connect to here. And then here it goes up, but it has to come back down to connect to there. And then here the function continues increasing, so derivative continues to be positive. And on the other side, way over here, the function is increasing from the left, so derivative is positive going this way as well. So there we go. There's the graph of the derivative h prime of x. So now we know how to sketch the derivative of a smooth function from the function's graph. And in the future, we'll also learn how to sketch the derivative of a non-smooth function from the function's graph as well.